Hello and welcome to this GigaOM Pro webinar sponsored by CloudSigma. How to make big data work in the cloud and protect it without going broke. My name is Paul Miller and I shall be your moderator today. Before I introduce our panel, let me tell you something about the webinar console. Alongside the main window showing today's agenda, you should see an area in which you can submit questions for our panel. This Q&A area is important and we invite you to use it throughout the webinar to submit questions for our panel. There will be time at the end of the webinar to address as many of these questions as possible. We may also be able to address some of them as we go along. Now let me introduce today's panel and invite them all to tell you a little about themselves. As I said, my name is Paul Miller. I'm a GigaOM Pro analyst and founder at the Cloud of Data. Today I'm going to be your moderator, which hopefully means you won't actually hear very much from me. Next up we have Joe Maitland. Hi Joe.
Hi Paul. Hi everybody. Thanks for joining us. I'm the research director for GigaOM Pro's cloud and big data infrastructure practice.
Excellent. Thank you, Joe. Next we have Dana Gardner. Hello Dana.
Yes, hello. Great to be with you. I'm president and founder of Inter Arbor Solutions. I track cloud and mobile and big data topics. I'm also a prolific blogger and podcaster. It's good to be with you.
Excellent. Thank you, Dana. And last but not least, we have Robert Jenkins from our sponsor today, CloudSigma. Hello, Robert.
Hello, everybody. Hi, Paul. My name is Robert Jenkins, and I'm the CTO and a co-founder at CloudSigma. And we're a public infrastructure as a service provider, and we operate in Europe and the US.
Wonderful. Thank you, Robert. And before we get into the meat of today's topic, I'm going to pass back to Robert to say a little bit about CloudSigma as our sponsor today. Robert, back over to you.
Thanks, Paul. Yeah, so just to give you a little bit of background on CloudSigma, really the motivation why we founded the company back in 2009 really came from the personal frustrations of the founders, of which I'm one of them. And really it was with the frustrations we had with existing public clouds on the market at that time. And frankly, those frustrations are the same frustrations that a lot of customers have today with public cloud. So fundamentally what we wanted to do was create a blank canvas that allowed people to build what I would describe as grown-up cloud infrastructure without sort of false restrictions and a lot of the proprietary implementations that we were seeing in a lot of other public clouds at that time. So the result is the CloudSigma cloud. That's what we built from scratch. It's our own cloud stack. And basically, the idea is that it delivers pure utility billing, no fixed server instances, so you've got perfect provisioning, and a lot of other power features are exposed to the user, with the idea that you can then essentially build nuanced cloud infrastructure and get great performance. And you can look at our that's growing rapidly as a result of this. And it includes people like iStream Planet. They do real-time transcoding from satellites via our cloud. We have CERN around physics. To have sort of Web 2.0 type stuff, NBA, Halo 4 mobile games, they all run in our cloud as well. So it's an interesting customer base, but in common is a lot of that kind of power, the ability to take control and have flexibility in their cloud. So Paul, you can show the next slide. So essentially, what all our customers have in common is that they really value the flexibility and control that we offer them. They have a clear idea of what they want to create. They understand their applications, and what they want to do is build nuanced cloud infrastructure. And so what we do is to get in the background. We want to be the silent partner that delivers that, essentially. And that means allowing them to purchase efficiently, deploy those resources efficiently, and stay within budget. And that's really, if we achieve those aims, we're doing our job, as far as I'm concerned, as a public cloud provider. And so it's no surprise that we attract the sort of customers that we do that are able to sort of leverage those sort of value propositions. So I'm really looking forward to hearing the discussion and participating in the discussion with we have on the line today, and also hearing people's feedback and questions on the subjects we want to cover today. Thanks, Paul.
Wonderful. Thank you, Robert. Okay, so let's get going then and start digging into some of the meat of this topic. And first up, we want to look at this whole question of selecting an infrastructure as a service provider specifically, I guess, for dealing with big data. And as we go along during this conversation, we're going to have a number of opportunities to introduce some poll questions. And we're going to go to the first of those now. Let me just see if the magic works. Okay, you should be seeing a poll question in front of you on the screen just now. If you could just take a look at that and share your answer in terms of where you process your big data at the moment. And once those answers are in, we'll take a look at it. But while those poll results are coming in, Dana, coming to you first, how does a potential user, a potential processor of big data even begin to decide whether to use public, private, or hybrid? You know, what's the first process to go through in terms of making a decision?
Sure, thanks. Well, you know, we have to assume that if the organization, the enterprise, is doing big data, then they've already got infrastructure of their own, probably dedicated hardware or a traditional infrastructure, and they probably have been dabbling with cloud themselves. And the overarching problem with big data, of course, is the size. You need to keep adding nodes and clusters. You need to be able to support stacks of NoSQL or other data environments. You need to have Hadoop capabilities. And so it's the scaling and the speed of bursting these environments to handle your demands that I think has got people interested in going to more public cloud or hybrid cloud environments. So I have to assume that you're not going to just start doing big data by going to a public cloud. The public cloud providers, frankly, are not ready for you. You need to have expertise and knowledge about this. To me, this is really augmenting your existing capabilities with an eye on economics and the ability to burst and take advantage of elasticity that a public cloud provider can provide for you.
Okay, thank you, Dana. And just taking a look then at the results. 24% of those responding aren't using the cloud at all to process their big data. They're using dedicated on-premise hardware, which I guess companies like Oracle and DMC will be pleased to hear. 32% are doing it in some sort of private cloud, 11% at the public cloud, 11% using hybrid cloud, and 24% using some sort of other. Joe, from the sorts of people you've been talking to, you know, through your work at GigaOM, does that make sense? Are these the sorts of decisions and the sorts of choices that you're seeing a lot of people out there in the market making?
Yeah, the private cloud number definitely makes sense. I'm surprised that the hybrid number isn't higher, actually. And you know, I would have, if I had to guess at what these percentages would be, I'd have put public cloud at like 5%, you know, and hybrid at more like sort of 15 to 20 or around there. Because I think most enterprises that are have a cloud strategy, most of them are thinking of it in a hybrid way. So, you know, we'll consume some services in the public cloud and we'll build out, you know, we'll extend our virtualization infrastructure internally towards the private cloud model. So there's sort of, at least our surveys show that the hybrid is the dominant consumption model. So that doesn't look quite the same in this picture. But, and then, yeah, I'm also not surprised though by people thinking about dedicated hardware, because we're talking about processing big data here. So, you know, the big boxes from EMC and Oracle, etc. You know, they call them, you know, engineered systems. So if you have the budget, they're an interesting proposition for, you know, Fortune 50 size companies, and they're definitely selling them. So it's interesting.
Indeed they are, yes. So, I mean, looking then at the broader picture and coming to you now, Robert, I mean, at CloudSigma, as one example, you have, you know, data centers in Europe, data centers in the States. When it comes to processing and computing with big data, where data volumes are clearly a large part of the problem, how much does that physical location of the data center come into play?
I mean, it clearly does, depending on the type of data that you're looking at processing. And I think this also hooks into the very valid points that Joe was making, hybrid being a dominant model in this sector. And we definitely see that as well. And so really, they want to know the location, they want to know where the data is being processed, particularly if they're working in a sensitive area, maybe doing big data across healthcare information, that kind of thing. Clearly, the jurisdiction, the location matters, especially so in a more fragmented market like Europe, where essentially you have different regimes about handling of that data. So obviously within the US, you have at least a relatively homogeneous treatment of that kind of data, whereas in Europe, if you have French customers processing their data in Germany, it can cause problems. So the location does matter still in the cloud, both from a performance perspective, but also, sadly, from a legal perspective in many cases. What I would say was interesting is also from a cost effectiveness, location also matters, because if you're having to move big data, the kind of clues in the name, it's big. So it can actually be very expensive to move it around if you're talking about petabytes of data. And that's where the sort of effective networking strategy and having effective sort of hybrid setups is important. So if you're really planning on moving large amounts of data in and out of a public cloud, for example, as part of a hybrid, it really matters the networking effectiveness. So for sure, it's an area that we, in terms of making it cheaper and more effective, connects into cloud. You see that happening with a lot of different, well, not a lot, but certainly certain public cloud providers now are able to do real private connections without VPN that can essentially handle large volume between dedicated in-house sort of legacy systems or sort of active in-house systems, but also talk to the cloud effectively. So that's definitely something that's really important, I would say. But also one of the things that is also important is the moving on a little bit is sort of storage and that kind of performance aspects, but I'm sure we'll cover that in time. But that's actually something that there's a lot of work going on in public cloud as well, to be able to handle the multi-tenancy and to sort of start to deliver the types of performance that people can achieve through private setups as well. But yes, for sure, location matters, and the latency and the throughput of those connections, and also the cost is really important for the customer. So being able to patch effectively at a low cost, and for that data to be able to flow quickly across that connection in a hybrid setup, which is the dominant model that we see as well.
So coming back to you, Dana, I guess when we're talking about big data, the cloud solution, cloud technologies create quite a complex set of issues, because you do have large volumes of data to move around. So as Robert was just saying, latency and the like clearly becomes quite a significant concern. Sorry, there was some noise on the line there, seems to have gone now. Latency on the line, latency in the network is clearly a significant concern, but also the capabilities of the hardware as well. You know, a simple virtual machine that can handle running a website or processing CRM data is going to struggle far more when it comes to being part of a Hadoop cluster, say. How can cloud providers respond to this requirement for far higher capacity, far higher capability in the offerings that they're giving?
Well, that's right. The big data is different from just regular data, if you will. It does have different requirements, but I think that the technical speeds and feeds requirements actually speak to the cloud provider's strengths. This may be an area where they could actually be quite better than your typical enterprise. It's in their business interests to have a very capable hardware that they can operate at high utilization. They have a common data infrastructure that they can manage. They can pick and choose their hardware and their network and their componentry. They can engineer very specifically for these requirements. But what I see is different and challenging with big data is the security and control and access issues, because these are different and these might not be the strong suit of the cloud provider. So the onus is on the cloud provider to demonstrate trust and ability to maintain security, privacy, and access control. And this is a different type of security we're talking about. For your typical enterprise, the way that they protect their big data is to have a perimeter that's hardened and impenetrable. But when you take and move it to the cloud, you can't depend on the perimeter-only security. You need to have a secure infrastructure so that the software, the componentry has been architected for security issues. So there's a disjoint, I think, in transitioning from the enterprise to the cloud, because security can't be the same type of security that enterprises use. Cloud providers need to demonstrate that they understand that and have taken appropriate steps.
And are these the sort of steps that a cloud provider would be taking to simply be in business, or does big data raise different challenges for them?
It raises the same challenges of any of their operations, that it won't be very many security breaches before their business is challenged. People will know about it. Enterprises will share this. And so, yes, they need to have their speeds and feeds. They need to be performant in terms of making big data capable technically. They also have to demonstrate on an ongoing basis that they can accept this data, protect it, make sure that the access from both applications and practitioners, as well as separating it from other customers within that same cloud, have all been adjusted, taken care of, and that, of course, you know, the bad guys trying to get in are always trying new things. So it needs to be a dynamic and ongoing activity for security.
Okay, good. Now, I'm going to put up the second of our polls now, and while that is up, I'm then going to come back to the panel to ask them a question. So the poll should be in front of you just now. While people are responding to that, coming to you, Joe, one of the ways that a cloud provider operates a profitable business is by balancing out demand. So they have, you know, some customers are using most of the capacity on a Monday, so other customers are using it on a Wednesday night, and it all sort of balances out. So they get a steady utilization with demand coming and going from different people at different times. That works very well when the uses are of manageable scale. Presumably, once you start dealing with big data, the peaks and the troughs become worryingly large. How does a cloud provider plan for fluctuations of that sort of scale?
Well, I think they, you know, they have to operate a bit like, you know, any enterprise would have done in the days where they, you know, had to over provision. So I think, you know, for like Black Friday and you know, these huge kind of shopping days where everybody's online, you know, we know that Walmart definitely, you know, over provisions what they need in Amazon's cloud, which, you know, I think is kind of interesting because I think it's sort of a cultural thing. You know, you don't need to. The application should automatically, you know, as the use grows and more people are, you know, hitting that app, it should automatically scale, and it will scale. But I think there's still this reservation that companies have in using cloud services that they do need to over provision. So that means, therefore, that the cloud service provider sort of has to account for that, for these peak kind of traffic days. And then, you know, the very sophisticated cloud users, the sort of Netflixes out there, actually have engineered their app to be able to constantly kind of reconfigure across, again, in this case, it's Amazon's cloud, for where the capacity is. So as soon as somebody else hits a host that they're on, their app bounces off that one and searches for another one that isn't sort of in a multi-tenant scenario, that there's not so many other apps hitting it. So people are getting pretty sophisticated about using the resources, and the cloud providers I think just have to sort of keep up with that.
So,
just
Robert,
to add to what Joe was saying, yeah. Paul, you know, I think that the challenge of fixed capacity is something that happens all over the economy. This isn't a specific cloud problem. Whether you're talking about airlines selling tickets, or, you know, and everyone wants to fly at Thanksgiving or Christmas or whatever, you know, the local hotspot is in terms of traffic. These are problems that are actually well known, and utilization management and the methodologies around that are very well mapped out and understood. And really, as the cloud becomes more sophisticated, as cloud providers become more sophisticated, they will use the pricing mechanism and the sort of capacity planning that allows to actually be much better at continuously delivering. And really, I mean, just coming back to how we look at it as a supplier, sort of meeting that challenge that these guys were just outlining, really what we do is we try and get a blend of what we would call price inelastic people and price elastic people, meaning you have people that will essentially, you can imagine, backfill the cloud with background data processing, things like this, which, by the way, big data is great at, and you're talking about the customers we're talking about, like CERN and people like this. They have tens of millions, if not hundreds of millions of jobs that need to be done sometime in the next 3 months. It doesn't have to be done today, it doesn't have to be done on Friday, whatever. So what they'll do is they'll backfill our cloud. Whenever there's free capacity, they just fill it up. And basically, we sell that to them, but it's on a like sort of, if Walmart turns up and wants a server, sorry, CERN, you'll have to wait. Type basis. So essentially, you have different types of customers, and the key really for a cloud provider to be successful is to be able to blend those. So you combine the sort of price inelastic, the sort of we need the capacity now because we have people on our website type people, which are generally web services, and people that are like, well, I need to transcode this video, and I've got 48 hours or a week or whatever it might be. And the interesting thing is how that will develop over time, and what we see happening and what we'd like to see happening is the market really developing, becoming a sort of almost like a commodity where you can really buy capacity even forward. So you can say, well, I need it. On Black Friday, I know I need this, so I'm going to pre-purchase it, et cetera, et cetera. So you have the same sorts of trading and purchasing models that you see with many commodities, and we see that very much as a natural development of cloud, at least at the IaaS level. So that, I think that will happen. The benefit for the suppliers will be better capacity management that will come out of that. So for that, you need transparent pricing, sort of open marketing, trading kind of resources, which it's a win-win. The customers, they can pre-purchase capacity, they can secure the capacity they need ahead of time. The cloud providers can better manage their capacity and price accordingly. So we see that really as a win-win, and that's where multi-cloud and having a cloud that actually allows you to move data out and in very easily and move sort of and deploy multi-cloud. Because the flip side of the problem is, we didn't talk about, but if you have an outage, if Amazon or some major cloud had an outage on that day, everyone's going to be recovering over to the same cloud. So then you have a problem. So actually multi-cloud is something that I think is a healthy development for the industry in general, because it will allow people to deal with these sort of capacity issues much more easily.
Okay, so just sticking with you, Robert, for a moment, and coming back to the earlier question around, capacity and peaks and troughs in demand. I suggested that big data type jobs perhaps lead to greater oscillation in demand. So would you suggest that looking at your customer logs, that's not necessarily true, and that you actually see similar oscillations from small data problems, and that therefore things can smooth out just the same way you would have done in the past?
Yeah, I mean, I would say I wouldn't see a higher level of elasticity, which is basically what you're talking about, just because the job is bigger. But of course, it's a lot harder for a cloud to handle a bigger job elasticity than a smaller one. If you scale from 1 to 10 servers, it's different from 1,000 to 10,000 servers, or 10,000 to 100,000. So for sure that's the case. But that's not a problem that's solved anyway by using private cloud. People forget this. What are you comparing it to? You're comparing it to having your own infrastructure. Well, if you had your own infrastructure, you wouldn't have that elasticity in the first place. So yes, public cloud is not perfect, and sometimes there may be capacity constraints, etc. But on the other hand, if you provisioned all that stuff in-house yourself, you wouldn't have any elasticity anyway, right? So we have to be fair in terms of how we compare things. So the answer is yes, you can get elasticity from public cloud. It's not unlimited elasticity, and I think that there are a lot of interesting developments happening where, like I say, people can and are getting more sophisticated about engaging with multiple providers, which gives them a much more credible elasticity strategy, let's put it that way, because they're not relying on one particular provider at any one time. They can actually move workloads and things like this. And that's kind of something that it's not there yet, but it's coming, and we see more and more providers customers looking to be able to do that, to be able to pull down capacity maybe from Amazon, but also being able to do the same from Rackspace and maybe from CloudSigma and from other providers as well. And it's interesting how you're starting to get that. And hubs where, so for example, we're in SwitchNap in Las Vegas. It's the same building. We were there, and actually when HP launched, they chose the same data center. So customers, we have customers that private patch to us. They private patch to HP Cloud. They have their own private cloud, and they're actually just sort of plugging into all these different pools of resources. And what they want to do is be able to move workloads around dynamically depending on the requirements. So I think it's like a sorry.
No, carry on.
So I was just going to say it's absolutely, it's not a perfect solution. Public cloud isn't a panacea for all capacity requirements. On the other hand, it does give you elasticity, which private cloud doesn't give you. And most providers, most customers are in fact engaging with more than one. So they're using their own private cloud and increasingly one or more clouds, which is getting closer to the kind of more comfortable position of being able to actually meet these requirements. But let's not forget that if they didn't have public cloud, the only option would be to simply buy the hardware and keep it and have it underutilized for most of the year. So, we're not there yet, but it's a significant improvement on where we were maybe, 10 years ago when we didn't have the option of this elasticity in a public cloud. And from the provider's perspective, the way we solve that problem is by blending different requirements. So we shouldn't have Walmart and Macy's and blah, 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 and this is our sole customer base, because this would cause a big problem, as Joe suggested. But if we have people that do genetic sequencing, which we do, and high energy physics and weather prediction and things like this, they don't need to do weather prediction on Black Friday. And when our prices go up because Walmart spins up a whole load of servers, they will just turn theirs off and wait 3 days and do it then when it's cheaper. And using the pricing mechanism and transparent provisioning and pricing, I think for me, I see that as a solution. Now, I'm biased. I did economics, so that's why I think like that. But I happen to believe that that's actually what will happen, because that's how we handle everything in terms of commodity. And computing is a key commodity of the economy. So actually, it's really important that we get it right.
Okay, good. So you just said it's Walmart's fault when we don't get a weather forecast on the day after Black Friday. You heard it here first.
Twisting my words.
Oh, yeah, indeed, yes, but that's my job. So just turning then to the poll results briefly. Dana, security, the bogeyman of the cloud, is there at the top. Surprised or not surprised, or disappointed?
No, I'm actually not surprised, and this is appropriate. Big data decisions are strategic, and they're business decisions as much as technology ones. And some of the studies and research lately have shown that corporate board level decision makers are concerned primarily about privacy and security issues when it comes to these big data decisions. So naturally, we're going to have to address this, and trust but verify is important when you go to your cloud provider. They also need to demonstrate that they understand the architectural requirements around security, that it is different from enterprise security, and that if they can add the value of trust with access control, that's something they can monetize. We were just a moment ago talking about a commodity influence with computing in the general economy, and that it should follow the same trajectory of commodities. Well, what the cloud providers need to do then is have high value-added services, and privacy and security and access control that works, to me, is an extraordinarily valuable value-added service. So if and when, and I think it's more a matter of when, the cloud providers solve the security issue, and they might actually be able to solve it better than your average SMB or enterprise, this is going to be good news across the board, and it will validate their business model, because they can find a way to have a higher margin, not just on their technical capacity and capabilities, but on their ability to do the business side of big data, which is protect it, add more value, bring more data together in ways that will produce analysis that has not yet been perhaps possible.
Okay, good. Any final thoughts on the poll from you, Joe?
No, not really. I think everyone's still sort of voting in security. That is the number one challenge. And we heard this sort of the first round with in the late 90s, early 2000s, with the storage service providers and the ASP business model. That back then the technology and the infrastructure wasn't there to actually do these kinds of services, but also people were just very concerned about sending their data off to a third party service provider. And I think those fears are still there, and the industry has not met that challenge yet. And when they do, and I think that they will, and there's also cultural stuff too, we'll see, rapid adoption at that point. But right now it's still fairly slow because of the security challenges.
Okay, good. Thank you. And we're just going to move on now, but I just want to remind the audience, if you have questions for the panel, please do submit them, and we will cover as many of those as we can, either as we go along or in the Q&A period at the end. So, on now to look at a sort of related topic to what we've just been talking about, this balance between flexibility and simplicity in terms of selecting your cloud provider. Now, clearly, the dominant model in the public cloud space at the moment is to select one of a number of virtual machines from a fixed menu of choices. You get a small machine, or you get a middle-sized machine, or you get a big machine, or if you're Amazon, you get an extra big machine with fries on the side, as their naming conventions get odder and odder. CloudSigma is one of those that takes a different approach, allowing, well, Robert, why don't you tell people what your approach is rather than me doing it?
Yeah, sure. I mean, I think that, so what you're talking about really is a sort of menu-based model versus something where it's a customer-defined model. And clearly there are advantages to both approaches. Now, from what we see in our customer base, one of the reasons why we have a lot of customers in big data is that actually they get frustrated with the menu approach because they have very specific requirements. So big data tends to have a lot of RAM, like really a lot of RAM, and have a lot of storage necessarily, a lot of networking throughput. What they want is just to specify a machine, and if you have basically your return on, what we see, and this is a general point, is the large, when you're doing computing at scale, the return on investment in terms of actually refining that computing, it changes. If you have 5 web servers, you're just doing some website, you've got a little bit of traffic, database server, blah, blah, blah. Okay, there isn't a big return on investment to kind of really shaving that down and being really laser focused like a sniper on exactly how each one of those nodes needs to be configured. Now, if you have 1,000 of them or 5,000 of them, it does make a difference actually, because that $50 saving a month per virtual machine becomes thousands and tens of thousands of dollars. And so that's actually the point here, is that from what we see, that the actual kind of more sophisticated users, and I don't mean that in a sort of value judgment way, I just mean people that have to buy a lot of computing, so they tend to have a lot of in-house resources, IT, whatever it may be. Those guys, they want to be able to configure up their server. They know what they want. I'll give you a real example. iStream Planet was migrating their product to our cloud. They use big virtual machines to do a lot of CPU-intensive stuff, so it's not really big data, but it's a similar example in terms of what they wanted to do is they needed the NUMA topology, which is a complicated thing to do with memory address space and this and the other. They needed that, and they needed to dial it in because they were using Windows machines because of the codec. Now, on our cloud, they could do. It's impossible for them to do that in any other public cloud because they don't expose the options. So the only other option was private. So there are many, many examples. And with big data, we have another e-game. They do customer loyalty schemes. They wanted to be able to dial in their machines because they have thousands of them to be able to really be exactly what they want. And that's a matter of having tiered storage, using SSD. We haven't really talked about storage, but that really is a huge driver of big data in the cloud, because when you have multi-tenant data doing big data, it's actually really looks like random I/O to the provider. It's really important that performs. Otherwise, you end up having a lot of I/O weight. And actually, there's a lot of technical things like basically moving to SSD that can drive that. So really, the idea is that being able to allow the customer to say, I want this SSD drive of this size for that machine, and I want this amount of RAM and this amount of CPU for that virtual machine. To me, it's self-evident that you should allow the customer to do that, even if you were to present them with some fixed options if they didn't know what they want. To allow them at least to say, custom, can you please define this virtual machine? And for me, the idea that you could summarize the world's computing into 8 machines or 16 machines or even 30 machines is not credible. Computing is very complex. It's not going to become simplified overnight if we only give someone 16 options. It's still complex. It just becomes inefficient public cloud, onto private cloud. So I see a lot of the rolling back of the territory of private cloud by allowing customers to express their requirements in public cloud settings.
Okay, good. Now, Robert, we're losing you a little bit there. The audio was dropping out a little bit towards the end, but I think people probably got the substance of what you were saying. Now, Joe, coming to you, clearly companies like Amazon and Rackspace and others that have the menu-based approach must have it for a reason, and they're doing okay. So there's clearly a role for both approaches here. How do you think, from a sort of a customer perspective, they perceive the difference? You know, on the one hand, it's flexibility. On the other hand, it's complexity because I don't know where to go. And then you've got, you know, choice versus you know, an a la carte type approach. How do you think a customer can work through those options and understand who the best provider or what the best type of provider might be for them?
Yeah, I think I agree with Robert. You know, computing is complex, but I think the challenge for cloud service providers is to hide that complexity and make it as simple as possible to use if we're going to see sort of mainstream broad adoption, certainly by, you know, enterprise IT. And I think, you know, both approaches, there'll definitely be companies that want to be able to dial up, you know, RAM versus CPU versus, you know, storage and bandwidth and tweak all of those things and be very kind of hands-on and granular about precisely what they're using. And then there are companies that want the absolute opposite to that, you know, just give me, you know, a large machine, and they even find, you know, they find the Amazon menu too complex. So I was interested to hear Netflix at the AWS reInvent conference talk about how the CEO of Netflix talked about how we're in the sort of assembly line days of cloud computing services, and, you know, with Amazon kind of you know, lexicology around their machines, you know, M1 large and all these peculiar names, and you know, he says it needs to get sort of way simpler than that and way more straightforward. I think I happen to agree with that. So from the customer perspective, I think you have to figure out what your you know, what your application demands are, and do they fit into, you know, this menu-based approach, or are you going to need more granular control and kind of figure it out from, you know, your particular use case first, and then into the cloud scenarios.
And Dana, one of the things that Robert was talking about there was the need to be able to move jobs around essentially from one cloud provider to another, especially as demand increased. And clearly part of that in this sort of resource selection and resource management sort of aspect of things is to be able to understand how you compare like with like. So what is an Amazon M1 compared to a Rackspace doohickey, and how does that compare to, you know, the finally selected options on a CloudSigma control panel? Because even once you actually get down to things like the amount of RAM in a machine, you're still not actually comparing like with like. Some RAM is faster than other RAM, and you don't actually know what you're getting. So how do we start comparing these different providers in order to make effective decisions?
Right, so the customer does want to have basically what I call fungibility of being able to move their workloads, their payloads, and their data between different cloud providers. However, most cloud providers will talk the talk, walk in that regard, and it's in their business interest to try to make it at least a little bit sticky for the work to be done. The tension in the market between these forces, I think it's going to be more of an imperative because, as it was pointed out, there's such a dynamic nature to these big data services that you really do also need to put yourself with multiple sources for these services. You might also have regulatory and compliance requirements for the geography or location of the actual data centers. So we could look at standards as one way to do this. That would, require.
Sorry, we're losing you there, Dana.
Some intermediate. Sorry.
I think we were losing your audio there for a moment.
Oh, I'm sorry. I didn't sense that. But the point that I was getting to is the expecting the cloud providers themselves to manage this interoperability is probably unlikely, and to expect the customers to manage the complexity is unlikely as well. What I expect to see would be an intermediary organization or service that would come in and bridge this. It would say, we'll take your data and we'll make it fit multiple providers, multiple clouds. So think of this as an ecosystem. It's not just necessarily the enterprise and the cloud providers. There are going to be organizations between the two. And one very, I think, in-demand service will be to be able to allow data payloads to extend from one enterprise into multiple clouds. And for that organization to manage the complexity, you might think of it as a systems integrator type of a role, but in this case, it's in the cloud services ecosystem environment.
Okay, yeah, that makes a lot of sense. And Robert, at CloudSigma, you're involved in the Helix Nebula work here in Europe, and presumably that is one part of the vision of what's being built there by CloudSigma and its partners.
Yeah, I mean, he basically hit the nail on the head. That's exactly what will happen. You have ecosystems around certain industries and sectors, and they'll naturally congregate together. And so Helix Nebula is a good example. We're also building a media ecosystem, which is around sort of the movie production, television production industry, which is on the West Coast in the US. But turning back to the Helix Nebula example, yeah, so basically you had some leading scientific institutions in Europe, CERN being one, European Space Agency, another one called European Microbiology Lab, which does a lot of genetic research. And they came together and they said, hey, we can't buy from one cloud provider because it doesn't meet our requirements. And this is also not just from a capacity perspective, from a feature set perspective. So they said, we want to be able to have a science cloud where we can actually pump in, our workloads, and they will get allocated out over multiple providers. And we have a competitive market, we have transparency, we can understand performance aspects, all the things that you were talking about. And that's the aim of that project. So, we did pilot projects with them, running workloads from ESA, from CERN, from EMBL. That was completed last year, and now we're moving to the next stage, which is doing exactly that, which is creating a third-party interface as a broker function where essentially these big scientific institutions, I mean, to give you an idea about CERN, they run 250,000 CPU cores on average. That's one project at CERN. That's not all of CERN, that's just one project, the Atlas project, which was for Higgs boson, the initial aim anyway. That's one project, 250,000 cores. So they were looking to put that out onto public cloud long term. And so to do that, they wanted this multi-cloud interface. And so we've been running workloads from those guys, and now we're going into this multi-supplier type mode. And there are a lot of really interesting companies like there's one called Tap.in, there's another one called Compute Next, that actually are building really exciting platforms that do exactly this, that allow customers to essentially engage with multiple providers, and they're now building in features like the performance monitoring so they can actually contextualize the pricing. So I completely agree that these things aren't fungible, but also I think they'll never be, because actually you have purchasing cycles, you have lots of different things, so you're never going to have exactly the same hardware in all clouds at the same time. So you need some ability to adjust and put in context the costing and pricing. You can do that empirically yourself. You can go and run on 5 different clouds, of course. It's a lot of work. But even better, you have someone who's doing that actively for you all the time, and you can understand that this $300 server a month from this provider, how that equates in terms of throughput across multiple providers. Because ultimately, computing is a means to an end. It's not a Mona Lisa. You don't stick it on the wall. The value is through what it produces. And I'm totally in favor of having transparency on the performance side. And this is an aspect that's really been missing. You've had price comparison, but you haven't had performance comparison. And you need to marry the two together effectively to really allow customers to make an intelligent purchasing decision.
And Joe, where do you think this performance comparison is going to come from? And do customers need it as much as we think they do?
Yeah, they do need it, and I think once, as well as the security stuff, I think once this kind of performance comparison that matches up, is married with the pricing information is there, people will be much, more compelled to adopt services. But and there are companies out there that are trying to kind of create units of capacity that could potentially be standard across different service providers. So Fusion 6 has an interesting offering, and I think it has to get to that point. When we look at any other commodity service, the unit that's being traded is a standardized unit. So that's what we're missing still. And who knows where that's going to come from, really. And there are sort of exchanges here in the US that are starting to look at doing that, but it's very early.
Just one point to make quickly, Paul, on the commodity trading and that. Actually, commodities aren't actually exactly fungible, but what they do, they agree to a standard unit of measurement. So, for example, the oil market, the trading in oil, of course, oil from different wells varies in terms of sulfur content, all different technical things, and viscosity and stuff like this. What they do is they trade a standard unit, and then they actually sign a separate sort of contract for difference, which adjusts it for the quality of the oil that actually is delivered at the end. So, and I would see a very similar thing in compute, in that you agree a standard unit of compute throughput or measurement, and then actually there is an adjustment made based on, well, actually it's 1,333 megahertz RAM, not 1,666, etc. So these are all things that are already known, and it's just a matter of sophistication happening on the buyer side as much as on the supplier side to push for that. And I think it's very much coming because we see a lot of developments in that area.
Okay, good. Yes, and I'm seeing quite a lot of people talking about it more and more as well. 6 Fusion, which Joe mentioned being just one of them. It's going to be interesting to see, and it'll also be interesting to see how much you, the audience, respond to the sorts of services that begin to appear in this space. So moving on then, as we're nearly out of time, I guess we've covered a lot of this actually, in terms of specifically the processing of big data in the cloud. Does it raise additional issues above and beyond those issues that people need to face in dealing with any kind of data in the cloud? And I guess one thing that I was wondering about was, surely if you're a cloud provider and you're optimizing for big data type jobs, you're going to have very wide bandwidth, you're going to have fast storage like the SSD that Robert mentioned there, you're going to have very fast RAM, all optimized for handling large volumes of data very quickly. But doesn't that mean you're then over-specified for every other job? You're over-specified for just running my website, which doesn't get that many hits. You're over-specified for running my email system, which doesn't send that many emails. Robert, how do you deal with that? How do you balance out the technical and the business demands of high volume and low volume, I suppose?
Clearly, this is a business problem, not a customer problem, because we never had a customer complain about being over-provisioned, yeah? so to be clear.
Might
they
be paying for Rolls Royces when actually they only need Fords?
No, exactly, right, yeah, exactly. So the answer is that there's clearly going to be a balance. So you have, and you see that already, you have public clouds that have heavy over-provisioning, where if actually you really suck down all the resources that you're supposedly buying, you'll have a problem because they're very contended, right? So these are more like VPS-type clouds in the public cloud space. So I think you'll have some sort of strata happening in clouds in terms of their business model and their customer base. Because like you say, there is that. But the other thing is that, you're having technologies develop which allow you to deal with that. So, for example, to take your example of SSDs, because storage is really one of the main drivers of public cloud, or one of the big problem areas, and really the big differences between, the different use cases. So, looking at storage. So, for example, on the storage side, what we're now able to do with the move to SSD, and you'll see this coming across the industry, is that we can actually expose SLAs on storage. So actually, if you're a big data customer and you have a drive of 100 gigabytes or a terabyte, whatever it might be, let's say it's a terabyte, you can actually dial in the IOPS to be higher, and you pay a higher price because you want extra IOPS. But you have another customer that's very light usage, and they have it dialed down because they don't need it. So, you know, the technologies are solving some of these problems. But yes, you're right. I mean, ultimately, there is a breaking point below which you say, well, you know, if you want like the cheapest blah, 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 then yes, we're not the right choice. And that's fine. And likewise, you won't be able to achieve the sort of performance you want on another platform. So there's definitely going to be some specialization between different clouds. But I also think that you'll see technologies that will allow you to better dial in performance, especially on the storage side, and also now, very interestingly, on the networking side as well. So one of the big things that we're doing in 2013 as a research and also going into production with is software-defined networking. And you know, this has been talked about a lot, but really it's coming to public cloud in 2013, because I can tell you that commercially you can now buy software-defined networking-enabled systems that you can deploy and sell competitively, meaning in the public cloud, which you couldn't do before. So that kind of aspect of networking will mean that you can now start to bring in that networking aspect on the kind of differentiated performance. So I would say that what you have to do is sell performance and be able to differentiate between different performance levels and allow a customer to essentially dial in a minimum. So they can say, this drives minimum performance, I need this IOPS, this throughput, I need this minimum networking performance on this virtual machine, I need optimized networking between my big data nodes, blah, blah, blah. And if you can deliver that, you can run that and sell that as a value-added proposition. And at the same time, you can still have, you know, Joe Blogs with selling, you know, homemade jumpers or whatever it might be that doesn't need the performance, and he doesn't pay the same price because he doesn't actually tax the system in the same way. So I would say that a lot of those things are being addressed through technology.
Mark Andreessen was right.
So there isn't an infrastructure as a service. Don't let anyone tell you that there isn't, because there's a lot going on, I can assure you.
Okay, good. So Dana, either continuation or even an increase in segmentation amongst cloud providers. There will be those at the top end offering a premium service, however that is defined, and others lower down. And ability of software to tweak performance and tweak capabilities will allow some elasticity there, but we are still going to see this spread of providers, and there will be those optimized for big data and heavily trafficked websites, and those perhaps who are aimed lower down the market. Do you think that's going to continue, or are we going to see one big cloud provider to meet all needs?
No, I think we're going to see a tremendous amount of granularity when it comes to the services and the ability to match the right requirement with the right service. And that's very difficult in an enterprise where they have 4 or 5 year cycles of technology adoption. And just because software-defined networking is available, it doesn't mean that enterprises are able with their skills and their budgets to then adopt it. So, you know, we should think about this as more of a fundamental shift, because a cloud provider can go about the early adoption and due diligence to bring in the best technologies and then segment those technologies to just the right payloads and customers with the appropriate SLAs far better than your typical enterprise IT department. And this is what's really making cloud so, I think, attractive, is it allows for a specialization with the economics that work, rather than a general approach to IT with the economics that work in an enterprise. And when you think of it in that way, it's only inevitable, really, for more and more of what IT does to become part of a cloud services portfolio. And it should be a portfolio. And, you know, one of the other things about buying services, software, and hardware from a vendor is that it's in their best interest to create a mass market product. That's how they function well. That's how they make their shareholders happy. But that's not necessarily what the buyers want. So cloud really has an opportunity to change fundamentally the way that IT is procured, delivered, and matches the requirements of the buyer with the capabilities of the latest and greatest technology.
Okay, good, thank you. And we've had a question come in from Rich Miller, who is no relation, so it isn't a planted question. This is real. And he says, thinking about the security aspect of things, big data in the cloud, what issues can a cloud provider help their customers work through in terms of regulations and policies around security and data residency. Is this something that's the cloud provider's job to fix, or are they simply offering a bucket into which the customer is putting things and it's the customer's responsibility to ensure that they meet the regulatory and security requirements? Joe, any thoughts from you?
Yeah, well, right now most cloud providers definitely don't support the customer in terms of figuring all of that out. Amazon specifically says in their in their agreement that the legal and regulatory issues are are on the customer. So, but I mean that's one thing where I think there'll be service providers, and they're already cropping up that specialize in that. So Terramark, the company that Verizon acquired, has a lot of business with the government here in the US, purely because they went down the path of providing the best kind of compliance capabilities within the cloud, the cloud context. So, I think, you have to sort of like weigh what it is that you're really after. Amazon and Google are kind of in a race to the bottom in terms of price. Rackspace is kind of commoditized support. They have the whole fanatical support thing. CloudSigma here is showing you how you get a better performance cloud. So it's sort of, you kind of have to figure out what the most important thing is and match your service provider, your cloud service provider, to that need.
Robert, what role can you play at CloudSigma in helping a customer to understand the requirements and helping them to meet them?
Yeah, obviously we've got to be very careful about giving people direct legal advice because we're not qualified legal advisors, right? So that's the one thing. So circumspect about how we do that. On the other hand, we do. So I would say the way we deal with it, we see this a lot more in Europe than we do in the US, unless we're talking about healthcare or government. You have it in every industry in Europe. Basically, what we do is we work with lawyers who are very well aware of and understand the way our cloud works, the locations, the treatment of data, etc., and are aware of particular jurisdictions and requirements. I'll give you an example. We had a systems integrator who was working for an insurance company in the Netherlands, and basically they wanted to do processing. And although we're opening a cloud in Amsterdam, at the time we didn't, so they were looking at doing it in Zurich. So we helped them contact a lawyer that was understood international data requirements in Europe, and they were able to then liaise with them to put in place the right documents and treatments and essentially formalize the role between us and them as a systems integrator to make sure that they were compliant with the relevant legislation in the Netherlands. So, I don't think we can possibly understand and keep up with all the requirements across all countries, all industries, etc. It's impossible. What we can do is be aware of be cognizant that it's an important requirement and then actually point customers in the right direction and, of course, be transparent. What we can do is be transparent, and you don't get that from a lot of clouds as well. It's improving, but you still, in many cases, a little bit obscure about their security policies and treatment and things like this. And the very least that a cloud provider can do to assist the customers is be able to be transparent about those kind of aspects, which allows them to then see if they can be compliant and use your cloud, etc. Because if you don't have the transparency, they can't really start to begin that process.
Good point. Yes, thank you. Okay, so we're almost out of time, but I just wanted to address this final topic here as briefly as possible, and then we'll have a moment to look at a few more of the questions that have come in. Is there value, and Dana, you can take the first stab at this, is there value in a sustained relationship with your cloud provider? One idea is that the whole point of infrastructure as a service is you simply stick your credit card in, get some computers for a few hours or a few days, and then throw them away again when you're done. That sounds good. A series of one-night stands essentially with different cloud providers. But is there value in building a longer, more sustained relationship with one provider or a small group of providers?
Well, I certainly think that at the bottom of the food chain of technology services, and I suppose we could look at infrastructure as a service in its most bare terms as being there, you're right, it's a one-night stand, but very rapidly we're seeing a maturation in the market that means there are value-added services, there are more applications and specialization, and so when you move to something like big data and business intelligence and analytics, this really should start to become more of a marriage than a quick date or, thinking about the right partnership for long-term value. And so I expect to see actual interdependency between some of the largest enterprises and some of the cloud providers with that ecosystem between them ever churning and ever adapting to provide more specialized services. But this is going to be a long-term partnership. And I think enterprises need to think about it that way.
Joe, what about you?
Yeah, I think it always depends on the use case. If what you're doing is strategic in the cloud, then you want to have a strategic relationship with that provider.
Okay.
If it's not hugely important to your business and it's a sort of, not a mission critical service, it's just something you're kind of crunching, at the weekends, then, you don't need to spend time and invest time in building that relationship. But if you're doing strategic things, then you want to know that that partner you're working with is on the same page.
Robert, do you want to marry your customers?
Well, as we know, a marriage, we don't want shotgun marriages, let's put it that way, right? So I think that it's important that cloud providers don't lock customers in a way that sort of they feel coerced into some sort of long-term relationship simply because it becomes economically difficult for them ever to leave. I don't think that's a healthy situation. Obviously, all providers want to keep their customers long-term, but so I think that the foundation should be essentially an ability for customers, if they want to move out of the cloud relatively easily without being too onerous about how they do that. But on the other hand, yes, I mean, for a lot of customers, in particular the sort of cloud that we have, it's more strategic for most of the users. So yeah, so the reality is they really do care about the relationship with the vendor. But this is a strength for someone that's obviously a smaller provider from someone like Amazon, because we can have much more of a meaningful relationship with that particular customer than we can with a provider that's operating at a much bigger scale. So it swings and roundabouts. So you are working with a smaller provider, yes, you'll be able to have a much more strategic relationship. And I mean, just talking about our methodology, we have agile, very agile, we use agile Scrum, Tweak, Sprint. We actually are very responsive to customer needs. So when we have key customers and they come to us and they say, oh, we really wish we could do this. If we can do it, it's in the product like 2 months later, live. That's the kind of benefit. And the reality is, because a lot of these requirements are complex, you need that. I mean, a lot of these people, when they're giving up private cloud, they get really nervous because they're stuck into a public cloud, and they say, well, what if there's some small thing and it doesn't work and I need a small change? I don't have any ability to communicate that and then really make sure that happens. So that's a really big concern that we see. So I think that it is strategic for a lot of companies, and there's no real getting away from that. And the reality is that companies want to have a proper dialogue with their cloud provider, particularly if it's strategic and important to their business. And let's be honest, the people that do most of the computing in terms of volume, big customers like the enterprise IT guys, it is strategic for them. So I mean, there's no getting around it. So basically, the way we see our market, addressable market, is actually most of the market, because actually most of the deployed computing in this world is operated by sophisticated users who operate at scale. And they operate, it's like 80-20 rule.
Okay, good, thank you. Now, we are over time, but I just want to take one more of the questions that have come in, and I'll go to each of the panelists. If you could give a nice brief answer, and then we can let people get off and on with the rest of their day. This question comes from Martins Adegoke. I hope I pronounced your name correctly. And Martins says, companies like Oracle provide a complete platform for cloud computing, private cloud, and sort of big data processing from disk to application to infrastructure. Are enterprises with a big data problem to solve not better choosing their solution from a provider like that, who owns the stack from top to bottom, than picking and choosing components off the shelf. Joe, do you want to briefly take that?
So is the question, an engineered system from Oracle versus a cloud service, or an engineered system from Oracle versus build it yourself prem?
I think it's an engineered system from Oracle versus sort of cloud services, I think.
Cloud services, yeah. Well, I think they're very, very different. There are very different benefits from each one. And at least from what I'm seeing in the marketplace, especially around big data and engineered systems, companies are doing everything they can to avoid being locked into their existing kind of data warehouse scenario, whether that's like Oracle or Teradata or any of those guys, and try and purely because they're so expensive. And there are many, many more economical ways to do big data processing now, whether that's through open source platforms like Hadoop, or moving into a cloud model where you're paying, only for what you use and when you need it, and only when you need it. So I think that model of buying a heavily engineered, albeit pre-integrated system from Oracle is going to be the sort of the smaller number of companies will do that, and most people will look at more sort of economical, newer ways of processing big data.
Okay, so a lot of it may depend upon how much data you have to process and how much of every day is spent doing that, I suppose. If you're processing
exactly.
terabytes all day, every day, then maybe a dedicated thing is the answer.
Yeah.
Okay. Dana, any brief thoughts from you?
Yeah, I don't think one size fits all is the right direction to go in, and the fact that a cloud provider and an ecosystem of cloud services can be fleet dynamic, react to the market, be specialized is really the alternative to what Oracle and others like that are offering. So I actually think that that's a blast from the past, and I don't think it translates very well into the cloud era.
Okay. And Robert, final thought from you on this?
Yeah, I would say that really the choice is between a vendor-specific solution and a general solution, and it would depend on the company. It's a defensive move from Oracle to try and retain their customer base that may be tempted into PaaS database as a service type solutions and just running things in the cloud. And so, from their perspective, they're trying to retain their core customer base, but I think it will get eroded by the alternatives and by public cloud, because it is a one vendor solution. So if you're in Oracle's cloud, you better hope that Oracle always has the best solution for you. Now, for many people, they may feel that is the case and they're very happy with them, and in which case they'll be interested in using the Oracle cloud. But I think one of the benefits that Dana picked up on earlier of the public cloud is that you can have access to many different systems. So, one of the things that I would like to see in public cloud and develop more is not some sort of benevolent dictatorship where the cloud has a database as a service and they say, this is our database as a service, but actually it has a choice of database as services provided either by the cloud provider or by external vendors. And that gives you a very powerful choice that you can have in a public cloud that you couldn't possibly maintain internally, to have all those types of databases or all those types of storage systems or things like that. So I think if you go back to a sort of vendor-specific type solution, you're back in that world of more of a typical enterprise world where you make a choice and you stick with it, and you do lose a lot of that dynamism. But for sure, I don't think Oracle's going anywhere anytime soon.
Okay, good. Thank you. So thank you then to Robert, to Dana, to Joe, and to all of you for listening and participating during the webinar. Thank you very much, and we'll see you on the next one. Goodbye.